Okay, welcome back, everyone. Last time we were together, we introduced the idea of the derived unit, where we combine multiple base units to form some new unit. And we looked at speed as an example. Today, we're going to look at density. Density is an intensive physical property of substances that is something we need to define. Essentially, density is this: how much mass is in a given volume of that particular substance. So if you think of something like gold, it's a very dense metal. If you had a small piece of it, it would feel very, very heavy to you. Take, on the other hand, something like, I don't know, a marshmallow. A marshmallow feels very light compared to the size or volume that it takes up. So typically, when we talk about density, density is given in units of grams per centimeter cubed or grams per milliliter. Both are the same because centimeters cubed are milliliters. That is mass over volume, grams over milliliters. The equation for density is given by D equals M over V. And we're going to practice today by looking at a couple of different problems. But before we get there, I want you to know some things about density. Typically, the most dense substances tend to be solids. The least dense substances tend to be gases. And liquids are often not in the middle, but closer to solids than they are gases. There are exceptions to every rule. So, for instance, in this picture, we're looking at solid ice floating on top of liquid water. Less dense substances tend to float on top of more dense substances. So, in the case of water, the solid version is more dense than the liquid. We know why that is. We saw a molecular level view of water that explained this. The triangle that you see is often used in like middle school classes to help students with rearrangement of the particular equation. How does it work? Cover up one segment of the triangle and it shows you the relationship that defines that segment. So if you were to put your hand over, say, density right here, the relationship that's left is mass over volume. Likewise, if I went back and I were to look at or cover up mass, the relationship is density times volume, and so on and so forth. Let's do a couple of problems involving density. By the way, I said density is an intensive property. What that means is it does not change depending on how much of the particular substance you have. An ounce of gold will have the same density as a pound of gold. A pound of gold will have the same density as a kilogram of gold. So it's a good way of identifying a particular substance. Anyway, on to our first problem. What is the mass of 34.56 milliliters of a metal if its density is 2.699 grams per milliliter? Let's take a look at this problem by first identifying the variables that are given to us. We're given 34.56 milliliters. I need to recognize that that is a volume. We're given 2.699 grams per milliliter. I need to recognize that that is a density. We're being asked to find mass. Well, if density is equal to mass over volume, I can use my triangle or just some simple algebra to see that if I want to calculate the mass in this particular case, I need to isolate that variable. So I'm going to put volume over on the same side as density. I do that by multiplying both sides by volume. It cancels out on the right-hand side, and it gives me an equation. Volume times density is equal to mass. So we're good to go. I'm going to plug into this equation my volume, 34.56 milliliters. I'm going to multiply it by 2.699 grams per milliliter. I'm going to cancel units. This is a good practice to get into. This is how you do that. Here I have milliliters on top. Here I have milliliters on the bottom. They cancel with one another. If I solve for this by multiplying these two quantities, I get mass is equal to 93.28 grams. It's more complicated than I'm about to explain, but usually you're going to keep the same number of digits as the item with the fewest number of non-zero digits in the equation. Since this has 4 digits and this has 4 digits, I'm going to keep 4. In a week or so, we'll learn that it is a little bit more complicated, and we'll figure out how to decide how many digits to keep in our answer. Let's do a more complicated density question. In this question, we're going to find density through a method known as displacement, volume displacement. The question reads, a measured mass of unreactive metal was dropped into a small graduated cylinder half filled with water. The following measurements were made. The mass of the metal equals 19.611 grams. This would have been measured on a balance separately. Then there are 2 pieces of information about volume. It says the volume of the water before addition of metal was equal to 12.4 milliliters, and the volume of water after addition of metal is equal to 14.9 milliliters. This is a useful method known as displacement. Take a look at the dinosaur on the right. If I look at the dinosaur, I can find its volume by first measuring the volume of a cylinder of water that has nothing placed in it. So if I look, I can read this one from roughly the meniscus. Afterwards, I place the dinosaur into the cylinder, and I notice that the volume of the water has increased. The difference between those two values would be equal to the volume that the dinosaur itself takes up. That's how you find volume through displacement. So in this particular problem, we're told that the metal with the cylinder is equal to 14.9 milliliters, and the cylinder without the metal is 12.4 milliliters. The difference of those should give us the volume of the metal that went into the cylinder. This comes out to 2.5 milliliters. The mass was given to us in the beginning of the problem. It's 19.611 grams. So if I want to find the density of this metal, density is equal to mass over volume, plugging in 19.611 grams and 2.5 milliliters. I calculate a density of 7.8. And that is with units of grams divided by milliliters, our unit for density. I'm keeping 2 digits there because my volume after subtraction came out to 2 digits as well. I hope that helped, and we're going to practice a few density problems right now.